Okay, we are live. Welcome to now is the fourth, let's say lesson of this creating the RISC-V console. I mean, it's more like a tutorial of using chipyard, but you get me. So let's continue where we left the other day. So at this point, we managed to do the RISC-V console. I mean, you can create a Verilog file, wrap it already to a future what is named the ULX3S 3S, and that's pretty much it. We only have the RTL code, so from here is the actual implementation to the FPGA. And we are going to use the open source tools for that. So I have experimented a little with the ULX. I mean, I also did it with the icebreaker, and it's kind of similar. So if I go to the ULX3S, I have here the list of stuff that is necessary. Well, I have here this Fuge Pro. I have this next PNR and the project Trellis. So you need to compile first the project Trellis. Then from here you use an next PNR as and use this project Trellis as a dependency. From there you just need to use the Fuge Pro, and the Fuge Pro is just for uploading your .bit file to the FPGA, and that's pretty much it. All the steps are definitely inside of this documentation that is named ULX3S toolchain. So the whole toolchain is ready to install and download there. And it's for lazy people. I mean, it will download and install all the executables necessary for that. You will also need the ULX synthesis tool that we are going to use in a minute. I updated all of the tools up to the last point. I mean, I did that in last week. I thought that last week we were going to do the FPGA flow, but no, it was not there. So yeah, that's pretty much it. You need only those. So we are going to add some other rules into the make file of the Verilog file. So let me see, where is it? I think it's get make file. So sorry, I have it here. I think I need it here. No, it doesn't let me. I'll delete this. Okay. Up to this point we have this common domain K that will add this will add the Verilog the Verilog rule. There's the default rule that we'll need that. So we need to add another rule. So let's start with the synthesis. So I'm going to put it here, the synthesis of the FPGA. And this step is pretty simple. I mean, you just need to add all the stuff into a script file, I think, or we can do it totally on time. I mean, we can execute it directly or using a script file for uses. I think I will go for the script maybe. I mean, scripted is better because if you do it in the make file, it will actually be a little messier. and we have these .f files that I'm not sure. So let me brief you a little about this. It will create Verilog files and everything that you need. Yes, that is totally a thing. But it will create these two harness at top files here, and each one of them will have the dependencies themselves about any kind of black box that is integrated inside of them. So a good old example is the plus R reader. This is exclusively used for the for the for the for the validator to work with the command line, but we don't need that into when we are going to do synthesis. So if you try to do synthesis with this, it will definitely fail. But if you do it without it, the reference to this plus reader is going to be lost. So that's a problem. We need to include also, I mean, when I open this, we need to put all the .v files and everything here, and we need to collect everything about that and put it into a list. It usually gets totally accommodated inside of a file, inside of a F file. So I think I will create this F file first before actually doing the synthesis stuff. And this will probably be more general than anything, so maybe I will put it into common, unless there's already a rule for doing that, which I totally don't think is going to be, no, definitely no. I mean, they have this thing here that will do the scene common files, that will have the scene files, the top black boxes, and the harness. Let me see which thing here is the actual stuff. No, definitely not here. So because we are not using this, there's no such thing. What about the scene files by themselves? It's not there as well. Scene common files. It's just that we don't need actually the same files. The same files are just utilities that are going to be used in Verilator or BCS exclusive simulations. So we don't need this, but we also need to remove the duplicate headers, as they did here. So I think I will go for doing only top and harness black boxes. Maybe I will add a simpler rule here. Let me configure this first. I will add a simple one here. Maybe just name it not sim, but maybe name it top and harness files. And then we add all the stuff here. That is definitely going to be the same as this one's. But then we need to also I mean, this is going to grab all of this and put it inside of this file here. We also need to declare which one is this one. That is defined in the variables. Okay, so let's see what is the sync common files. Okay, so I will do this one for the new one that we created, and we're going to put it in a fancy name, and that's pretty much it. So top and harness .v.f. Maybe let's name it like that. Then we need to actually make it available. I mean, for here is we just use the same BSRCs. The same BSRCs are this, the top file, the harness file, the top SMN files, and the harness SMN file. So it will commit to put everything about this one. So I will put this here, but it's going to fail. This thing is going to fail. Okay, we can instead of using this, we can put it here directly. Yes. I mean, we need it as a dependency anyway, so no sweat there. The top file and the harness file and the same VCRCs. So we also need as the dependency the VCRCs, and we need to add them totally into the total file. So this file in particular will be the one that will contain all the sources names that needs to be compiled. So I actually did this before. I mean, I can just grab the TI hardware for that purpose. I think I put it here. I mean, it's pretty much the same, so but I'm not sure what I did there. No, that is same files, same common files. I put it here, the same file, and then no, it's going to be the same. No, I think I did it for the FPGAs, for example, for the stylings. Yes, something like this. That I needed a VCRCs.f, and I needed to put it inside like this. So I just did an echo with this to the file, then the top F and this. Okay, we can do pretty much this thing. Okay, but this will do the default, so I just need to actually just do this. Okay, so I will put this echo here. I mean, it's pretty self-explanatory. Yeah, I just needed this thing. Just that I didn't remember what I did. But I think this is going to be a little hackish. I did an additional step here because I want these files to be totally separated by space. So I added this thing here. I mean, this is just a search that I did one day in Stack Overflow, like always. Yeah, about actually converting anything that is stepped like in new lines into spaces. So this will create a file that is named top and harness files, whatever this name, what it is named. We'll put all the VCRCs that we put there and create this .v file. So we need to put this into our dependency in the original make file. That will be this one. And if we do that, we can see this file. Maybe it will be like that. So let me show you and see if it actually happens. So we will create the files. Yes, the same files are not there. We don't need them anyways. Remember, we are compiling to an FPGA, not towards a Verilog file. Okay, we create the RTL file. Created the RTL file. Created the RTL file. That is going to pass through the stuff. You know, I listened this live before, and definitely something that is definitely a little annoying is the fan. Yes, it gets very. I mean, I try to adjust the microphone the way that it's supposed to, but no, it will capture the noise anyways. I need to be a little more professional. Maybe put this around here or something. Not sure. But sorry for the low quality, maybe. Uh, Well, anyway, right now it's converting the FreeRTL to the Verilog file. So it shouldn't actually fail at that point. It should be okay. Pretty much okay. Oh my god, do it already. I don't know why it's like a jet here. The fan is actually very noisy. Now the memory files. Created the memory files. Okay, we have this finally. So let's see what happened. Probably just going to import this one because I am stupid. Let's see. Gedit this thing. It only put this one because I did a little bad, and I put this to output, but this also is output instead of actually appending. So I need to append. For not doing everything all, I will just delete this file. So I run this one. Then I will run again the default. But it will do everything again. No. I am not going to do that. Sorry. I am not going to do that. I am going to just make this one. I'm going to run this command again. Then this command, but with the double angular parentheses. Yes, better. It's just a little change, so I don't think it's going to hurt. Oh, okay. Now this is another thing. So you can see everything in this file will be will import all the Verilog files here. All necessary Verilog files are going to be there. And we can put it like inside of a variable, something for use in the Ulysses. Okay, without out the hand, now we can actually do the Ulysses script. So as long as I am aware, for doing synthesis, the synthesis will create a JSON file. So we are going to create everything there inside of the generator SRC. Wait, what is the name of the generator SRC? The variable, the builder. The builder, and you will create the name of the top file. Maybe. I mean, we need to do it against a top file. The top file, the top module is named like model. So I will put that this file from now on will be named model.json. Yeah, the synthesis outputs a JSON. They have stuff there actually for doing that. Okay, for now I'm going to put this. So this is the dependency for JSON, and it will require these two because we need the default. Then I think we can do it like this. I mean, it uses P and the command. So I actually have it here, or we can put it inside. But I said that I wanted to use it inside of the of a script file, and this very script file will be this will be a little annoying. I knew it. So I think Yosis uses TCL for doing the stuff. So let me see if I can grab Yosis at this point and do the help for actually remember me what is going to do. Oh, here. Execute the script files and execute the commands in the script file in the TCL script file. So there's a script file and a TCL script file. Holy cow. Okay, this is the first time I actually did it. I need to see the blinky. So you saw here that actually in the ULX3S I have here a blink. This blink is actually the blink for the blinking example. It's only that. Oh, it's pretty simple. You just do read Verilog, sync ASAP, and this thing. No CCU, no MUX, no DRAM. Wow. I don't know what's happening. But we can just use this thing and put it inside of the put it side by side of the makefile. So RISC-V console. Yes, the FPGA, the ULX3S, and name it just start, yes, something like that. Put it like this. Now it will read the Verilog file, so we need to put this into a variable something. I think it supports it supports well, by the way, when I use P, I mean in the comment I use comments. So help for the help message for the specific comment, a script file, and TCL script file. So in the script file I actually can use environment as long as they are supported, or we can create this JOSIS file on the go, but I think that will be messier. No, I'm going to maintain that the JOSIS file will be the same, because maybe this file will needs to be modified, and I don't want people that actually wants to modify this JOSIS file to go to the make file and deal with a generator or something of sorts. The only generator here is the one that is going to generate the Verilog, at least for me, no? So we can name it all BCRCs or something. We can export this thing. Wait, I actually exported this. I don't remember. Let me. I am seeing here another code that I'm doing. Common file, the BCRCs. No, I don't think that this is going to work. This is going to work. I need to do it in maybe in TCL. I mean, they support TCL right now, so they support TCL right now. That is a bold statement. I'm not sure if they are going to do it. Maybe I'm troubling myself too much. What if I do this in a TCL file instead? I can read the file and put the Verilog files here. Yeah. Let's do it with TCL. And if the TCL doesn't work, then we will scrap this idea and say that is a dumb idea. Okay. So I need to read this into a variable. I know that TCL has a function for that, but I don't remember which one is. So like always, you will go to Google and see TCL how to refer into string, something like that. And as always, there's going to be some kind of stuff there. Then FPS of open some file L at set file data read FP. Then you close the file. And you can do process of the data file as well. Over a dot. I mean, I can do it like this. We only need to slurp all the data file. So it's some file. No, this will be the name of the stuff that we actually did just a while ago. That is named what? Yeah, this thing, the open harness. I need to export this thing into the environment, otherwise it won't read this one. But this goes with env, no? Env or end of the name. So I need to export this one before calling the YOSIS. So I need to wait, like this, export maybe top and harness files equals to this, or we can just call YOSIS with this environment in hand before, something like this. Yeah, can be like this. So the YOSIS thing will be what is the command again? You need to use either this one or this one. So this goes for TCLs. So let's do it with C. And let's put the same there, that is this one. Sender and YOSIS.tcl. I think that is enough. I mean, we still need to check this one. By the way, this is this thing, and this will be like this. It's the only difference, I think. It needs to. We need also the environment of the model and the environment of the environment of the of what? The environment of the, what's the name of this? Of the generated files. Why I always forget? I always forget stuff. I hate it. Model.json. Yes, the builder model.json. It will save it here. That's pretty much it. Yes? No? Yes? Maybe? I think that is enough. Yes, like this is okay, but I need to also do the model as model, and what else? And the builder as a builder. What a comment. Okay, let's try to do synthesis. I mean, it will create everything all again, so I will do all this thing again. Okay, but let's review what we did in the meantime. So we actually opened this file here, FP, this LRC or ref file, then close the file. Yes, totally okay. We have Verilog with the whole SRC stuff. Then synthesis. It's going to fail. I know that it's going to fail because there is a file that we haven't created yet, and that is the ROM file that needs to contain the program that you want to run into this. So right now it's going to fail because of that. But I wonder if I create maybe an empty file. Okay, we need to import some stuff. So there's actually a thing here that I did here about a script file for creating the ROM file. That is this one. I mean, I don't need you to tell you what is this file, what this file does, but basically it will just grab an hexadecimal file and put it inside of a Verilog file as a case. So we can just copy the whole stuff, save it, and that's pretty much it. So RISC-V console maybe inside of hardware, and I named this thing VLSI ROMGen. I think I named it like that. VLSI ROMGen. Let's put it like this. ROMGen. This will go here. And this is inside here. I need to put this as an executable. So if this is done, holy shit! But I make synthesis, no? Wait, make synthesis. Holy shit! What happened? What happened? I put synthesis as this thing. And this thing, the rule is to do this and execute the meiosis. What happened to meiosis? I want meiosis. I need to scroll these comments. What happened? You could create this and create this. There's a lot of echoes that I don't remember putting. Then put this. Then put that down. Oh my god, what happened here? I don't get what happened. I mean, it's a dependency, no? I mean, it should be there. Maybe some expert in this thing. I think, one moment. I am supposed to be the expert here. Ah, what happened here, man? I don't know. I don't quite know why this is. Ah, okay. I know what happened. I am using spaces. Ah, wow. This Mac files. This Mac files, man. Then it will run the YOSIS. So instead of running all of that, I'm going to run only the last command and see if it works. But it has an invalid command name. That is not named a real Verilog. Oh no. But the other thing happened, so that means that YOSIS is working with that. So YOSIS help, it will tell you what to do. So the TCL file is help TCL. If I do help TCL, maybe put something. Okay, maybe I need to put help TCL here and run this. Invalid command name help. Okay, there's no help. When it says help TCL, when it says help TCL, what the hell is happening? If I do help TCL, help TCL. Okay. Print the command list. I can do this one as well, but it says here it's TCL script file. Execute the commands in the TCL script file, but I can see help TCL for details. But where's such TCL detail? Help TCL. I don't see it here. I definitely don't see it there. No, definitely no. Ah, holy fuck, what happened here? I don't know what to do. The script file, I can do the script file as well. Script file. If I do H, what happens? It will list all these comments. And read Verilog doesn't exist? It exists. So what the hell? So I need to see if it's supported, but if not, I'm going to use just the regular stuff. So I'm going to search if YOSIS TCL. The TCL command YOSIS import can be used to import all YOSIS into TCL commands. Ah, okay. I can use that one. So I will move this yosis.yes to a dummy.yes. Then I will use YOSIS for actually doing this for me. That's good. That's a good thing. YOSIS import. But doesn't work. No idea what is happening. Ah, Clifford. How do I know the comments for uses? There are examples here. Maybe an example is here. Wait, what? The comment is the same. The comment is the same. What the? I am doing this bad. Wait. Josys demo.ts. I read Verilog, but it actually doesn't use the TCL. Why there's TCS file here? They bring project for this thing. Okay, if I do this and bash build does this thing, and yes, yes, definitely. I don't have any clue, but definitely doesn't work to do it like this. The TCL interpreter definitely did an invalid command name, and I am not sure what to do. So actually, maybe I'm going to push it a little further. Maybe its name is Yosus, like this. Some of the comments are like this. When I have experience in the other stuff. No, it's the same stuff. But the TCL in the examples, maybe I need to do it in Vivado, Yosis. Again, no idea. They also has something. No. Everything is GS and logic. The A here, maybe. No, I think there's no way. I think there's no way to actually do this. TCL, let's see, TCL Yosis. No idea. Definitely no idea. I'm going to stop. I'm just going to do it in the classical way. So it will be in this stuff, like literally there. So P, I'm going to do this as P, and just plain execute this stuff, because there's no other way. So I guess sorry. So I need to also what to do. It will be useful if I have it like this. It just that Joseph totally complicated this. I knew that it was going to be like that, but what to do? Okay, I can maybe put it like this. No, but if I put it like that, it's going to be totally. I'm going to screw it up. Wait, maybe I can put it like this. Maybe I can export it. Export. export and put it like this maybe, and do an echo of the total zip files. Oh wait, a cat. It's a cat. How will be interpreted this? No, I don't think it's going to work. I can do it with reversal type, with the reverse tilde as well. Let's see what happens. I mean, I can put it like this with the make file. This actually is accepted. Oh, okay, it works. I can do it like that. Yeah. I can do it like that. Yes. Sorry for that. So this didn't work. So I'm going to just grab this Jos's stuff. This Jos's stuff. Put it here. I am distracted. So read Verilog with this thing, then doing the other one. I lost my. That is just putting the other stuff. I don't have it open. So I will go and load this dummy and do it like this. RISC-V and no MOOCs, no DRAM, JSON, and it's going to be this thing.json. Let's see if it works. I mean, it should be. Let's put it before. This is not going to work. Maybe like this. Okay, what if I do it with double that? How do I do to escape that one? Maybe like this. Yes, like that. Okay, let's try it again. So we will export this one and do the Yosys. This is what I expected. The boot ROM is not there. So we can put something very simple. I mean, I will need to put I need to create a dummy X file. So touch dummy.x, get it, dummy.x. It's not going to work. It's not like I care. Wait, where's my... come on. Really? Whatever. I'm going to put this as 0000000. I know that this needs to have a space, a trailing space. and I need to do an additional rule actually. So in variables they have this mems.v, but we don't have a rom.v. So all the ROM files needs to be created in some way. So I'm going to create another rule that is for exclusively for the ROM file. So I will do it like this. I will copy this for copying, for the sake of copying them. I know that this is this one, but I know that that I need also the conf file as well. So I think it will be named something like this actually. But I need the conf file as well. So how is named the conf file actually? The conf file. I know that it's generated around. Come on, don't be shy. Where are you? Ah, yeah. It's pretty much named like this. Ah, holy shit, I need to disable it here a little. Sorry for this. Give me a second. Okay, ready here. Okay, what we're doing, we were actually trying to do generate the ROM file from this thing. So we are going to grab this script that I already told you that exists, that will create the Verilog file. So I will create it into this and grab the configuration file. Actually, it's named rom.v and the other one is rom.conf. That is the conf file. That pretty much will do it. We need to put this into the general configuration file. They actually do this using the simulation file, but if you want to change the program, it's going to be a problem. So that's why I put it explicit here. So I will create the rule for creating the ROM file for now. So for creating this from this one with this one, and also we need the file that we just created, the dummy.x. So we will put that x file. So Python 3, then go to the base there. That is named, that is in hardware, and VLSI gen ROM. The first argument I think is the ROM configuration file, and the second one is the X file. It's the X file. This will print something, and will be put inside of the ROM file that we want to create. Okay. Now we need to tie this into the other configuration file as well. So this conf file actually gets generated when it creates the stuff. So the FreeRTL file. So we need to add a a rule for the configuration file created from the dependency is from the FreeRTL file. So the FreeRTL is named like this. So I will need to put it like this. There is a lot of taking here. I think this is enough. But just in case, I'm going to just touch it. Touch the file. Okay. Ready here? Ready for doing the configuration file. It put the configuration file. It put the X. It put whatever. So it will create the ROM file from there. Now we need to add it to this mess here. And we need to also put it here as well. So it will need this as another dependency. Okay, perfect. We are ready to go. And now we need to generate everything. So make clean and make synthesis. But I'm going to check first if it's okay. Okay, I think it's okay. Let's do it. Oh, this is going to be a little long on time there. Again, we don't need the simulation files, so that just fails. Then creating the FreeRTL file. Okay, created the FreeRTL file. Then we create the FreeRTL from the barrel. It will create the Verilog file from the FreeRTL, both top and harness. It's cool to just wait, I think. You know, the hilarious thing is that this is just for creating literally a microcontroller, no? I mean, I know that this is not going to be easy, but certainly is not making it easier either. Wait, what? This file doesn't exist. Cat, this thing. How is named? Ah, it was named ROM Gen, not Gen ROM. I'm going to fix it, but I'm not going to run everything all again. I'm just going to run the last comments. Okay, so I think it failed here. Then Python 3 about this. Let's see. This is Python 3 or Python 2? I don't remember. It's just Python. Okay, so when I run it with Python 3, actually it's failed. Okay, easy enough. Just put Python instead of Python 3. I hate my keyboard. I don't have a home key. I need to go all the way to this thing. Actually there. Okay. So just for confirmation, I'm going to generate this ROM file. Yes, something like this. So the X file will be generated here, and it's named by my boot ROM. Okay, so we need to just run the latest ones. So all PCRCs with this, and the YOSIs. That's pretty much it. I'm going to run this one first because yes, not a valid identifier. Come on. It seems like I need to make it inside of the whole vertical stuff. No. It's because this X file is still not generated. It's dangerous to do it like that. I will put it here. I will put it there. No. I think I will put it here. Or maybe if I do it like this, maybe if I put only that. I mean, I am cheating it, but I mean all the time you cheat stuff, literally. Cat echo RBCRC. Perfect. I cheated. Okay, I cheated it. I mean, it's going to be ugly, but but whatever, it works. And now we need a bullshit name it AICG rubber. Oh my god. Why? That is part of the what is name it? That is part of the simulation files. We need to put that. We need to put that. Holy cow. Okay, we need to put it. Whatever. Because I'm making these videos too long. Then no. Okay, so I added the same files, but now the same file needs to have and stuff. So let's fix the bug about generating the same files. So it's sim name. So sim name is not defined here. It should be in variables. So sim name is not defined here. So it needs to be defined somewhere. So we can define it just here. Let's make it very later. Very later. Okay, very later. So then again we need to make clean. and make synthesis again, because we need to even do it like that. So right now, as you can see, is putting sim validator here. So it will create the validator files for that. But you know that is going to have a little problem, because if I put the validator file there, you will have some problems. It will try to read C files inside, something like that. But I wonder why the SAG actually got it there. I mean, I didn't use something like that. But whatever. Anyway, let's see the F file of the sim files. The ACG wrapper is there, so I see this. It's totally okay. It's just a latch. But it will create all this crap that is from very later, and the crap will continue to pile on because the sim files actually include all these shenanigans. It's not going to work. I need to put the ACG wrapper just as a hack. Same as I did it with the wrong file. So sorry for that again. So again, no, I put it like this. I need to put the SAG wrapper. So I'm going to put here something like the ACG wrapper needs to be added manually because very later. Yes, something like that. So I'm going to put here the a variable that is named the SAG wrapper, that is going to be just, you know, the builder and SAG wrapper .v. Then I need to add it to the cheater here, and everything I need needs to be there. It's a shame, but in contrast, we need to remove this and remove this as well. We don't need the same SRCs here. What? Wait, why did it fail to compile? Why it didn't fail to compile? What the? What did just happen? Oh wow, this is going to be a very long video, isn't it? Top and harness common. It includes even the CC files and other stuff. So no, this is going to be totally. No, I think it failed because of that. But module ECG wrapper reference in module in cell debug is not part of the design. The hell happened? It got totally okay. Look at this. I mean, this is good. But it says that the module ACG wrapper referenced in the platform is not part of the design. This thing. I don't know why I don't know why my design is using the ACG wrapper. I did not use this. I did not remember actually using this. I need to check the code, the generated code. But it's getting me a bad time actually. It's giving all of us a bad time. 1 hour and 11 minutes. Now we haven't got yet into the next phase, that is the place and route. I mean, the place and route maybe is a little autonomous. Not sure. Don't care. Okay, same error. Doesn't help. It says that module AICG wrapper referencing module is not part of the design. The blocks reader. I see that everything is in order, but I show maybe this thing. No, it doesn't create a log file, so I need to actually copy this into a log file or something to search for something. Okay, first of all, this is there. If I go here and put this thing, we will see if the AICG wrapper is actually... Ah, come on! No, it seems like it's literally not there. The MEMS, the ROM, it doesn't get... maybe I forgot to save the snake file? No, it's there. The file is there. it did not read this one. For starters, this file exists, no? Yes, this file exists, but it did not read this one. It read all of them, even the ROM file. If I check the log, it even read the ROM file, but it didn't create it. It didn't read the last one. Okay, you know what I'm going to do? Maybe it's because I already defined this thing before. So right now it's defined, so I'm going to just run the I am just going to run the ULX. Do it again. Okay, now passed. What the hell happened? Okay, it removes a lot of stuff. Then OPT expression, OPT clean, the music rights. There's a lot of stuff happening there. Now there's stuff there, and stuff here, and stuff like that, and that stuff there. A memory share. And I don't know what is happening. Oh my god. What is all of this? I mean, it's working kinda, which I'm happy. I wish the TCL will be working, but it's not. It's a shame, because that will be easier. I mean, the bug that we have earlier, it was because of the workaround that we tried to do about trying to put a file as the output of a file inside of an environment variable, and passing that variable into the comments of the ULX. Yeah, that kind of stuff. Okay, let's assume that this will be finished. And the next step is to just actually do the place and route, and the place and route shouldn't be that difficult, right? So the place and route, I mean, they have already a make file here. So if I do the, I mean, this needs to be back, but okay. So it seems like after the JSON, they need to do a config file and call this whatever. Something happened to my cell phone. No idea. Anyway, yeah. So it needs the output of the synthesis is a JSON, and the output of the place and route is actually a config. So we literally need to put a JSON, an LPF, and it will output a config file. Is that straightforward? Okay. Okay. It warnings and the JSON backend. Wow, this work like a charm. Okay, just do a little convenience with that stuff. So with the TCL. It would be nice if the TCL was supported. So place and route, no? So the output is a config file. To generating such config file, we need to have the JSON. The JSON and from here, from the sender, what is named? An LPF file. Something named like this. That should do it. Now I need that LPF file, and I know that I had it around, but I totally closed all my stuff the other time. I need an LPF file. Where can I get an LPF file? Maybe in the ULX3S GitHub. Ah, look, I have it there. This is from the actual ULS file, the constraints. We can just put everything here, everything about this. I will just copy it and paste it and put it inside of the RISC-V console in the FPGA, and we name it like what? I don't remember how was the name. No, stop it, don't search me. Oh my god. ULX3S version 20.lpf, something like that. I don't remember how it was named. It was literally like that. ULS version 20.lpf. So the actual command to go around with this is the one that we found here. So I'm just going to copy and paste it. No strings around. So I next PNR, the CP5, define JSON, the JSON that we need. I'm not the LPF that we have here. So we actually need to just copy this. And the text file that will be generated into the builder, and that will be enough. So but first I want to color this thing. I think it's something like TCL, something like. So do you remember this? Because I remember it very well. You need to match this with whatever we put inside of the RISC-V console, the shell. So 25 megahertz is there. FTDI, RDX and TDX is there, but the next locales are not there. I wonder if it will create some problems, but I think it's not. So everything that is named like this, I need to change it a little. So actually I'm going to change it. Everything that is named maybe it was W. Yeah, it's W. Everything that is W plus and starts with this thing, and I find a 0 to 9 several times and closes with the other parentheses. Perfect. I will put it into the original one, but underscore the other two replace. So it's let 0, let 1, let 2, let 3, like this, because this will be generated like this. Those are vectors, and the vectors get generated like this in the Verilog file. It's easier to access from here, but it's very difficult to do it from the Verilog stuff because of that. The OLED is not being used. We shall create it maybe. The flash is not used. The SD card is also not used. The audio is not used. The Wi-Fi is not used. The USB is not used. This thing is not used. What the hell? There is a lot of stuff here that I'm not using. But hopefully, if I put the LPF file, it won't fail. It fails to try to search the port. Let's see. Let's see if my assumption is correct. First of all, I'm going to check the PNR comment first. So it will generate the next PNR. Let's see what happens. Timing analysis failed due to presence of combinatorial loops. What? Where was the combinatorial loop? Where is the combinatorial loop? What the hell happened? Is this one? Okay, can be anything about this. So incomplete specification of timing, port, or etc. I mean, it would be easier to actually remaining includes. I think I need to actually just modify this one and try to just try to not lose it. Maybe something like this. I don't know what happened. Yeah, I am just using RXD and TXD. So the LEDs, the buttons, the SWs, the OLEDs are not being used. Okay, everything that is named locate or what? Where's the or IO booth? I need to put that exact one, but with a commentary. So let's find them. So this one, fine. Replace, fine. Replace. Fine, replace, fine. Replace. Everything about here now. Here, fine. Replace. Everything about this replace. Everything about here replace. Replace. Ah, holy shit, this is not the RAM. We need to use the SD-RAM in some point. At some point we need to do that. We need to do that. It's hunting me. It's hunting me right now. GN. Wait. Actually, the GN, we did use the GN, yes? The GP and the GN, yes. So everything about here is still there. Locate. Okay, we are ready. You only have, okay, I'm going to do a rundown. We have clock, we have FTDI, these things. We have LEDs, we have buttons, we have SWs, we don't have any of that. We have GP, and we have GN. Perfect. Let's do it again. Let's do it again, shall we? No. No. No, but Christian, you cannot map this until you dedicate here 3, 4, 5 hours to actually see what the hell is happening. The funny thing is that doesn't inform either if it is a combinational loop or is a specification of the timing port. Doesn't say anything about information about that. So we are totally blinded. We are totally blinded. I cannot do anything at this point. The next step is just to actually from the configuration file, from the config file, bring it to the bit file, and the bit file program it. So I think I will do an update to this file, maybe a little, maybe tomorrow, because I will look into this, but I will look at in the night. But pretty much is synthesizing, and pretty much is trying to do the place and route, but no, it just decides that nope, you cannot do this. Bad Christian, something like that, until we actually do it at the same time. So as for actually pass it through to the FPGA flow, I will say yes, but with an asterisk. I will inform you what happened, but right now, no idea. This was a failed run, but yeah, at least you already know how a flow works. I mean, this flow is very easy because we only needed like what? Everything from here to down is actually the stuff. So create the wrong file that we actually missed to do. This is where the future program is going to be. Put this SIG wrapper because fuck me. Put this read Verilog file to actually to work with YOSes, do the synthesis. Then same for the place and route, and do the LPF as well. And the LPF needs to match the outermost Verilog file, the top file. And that's pretty much it. I mean, it's a shame that we actually didn't get it to work it on in the intended way. So I will look into this. I will do an update video relating what really happened, and I will see you until then. Sorry for not actually having this stuff totally complete, but it's not a major deal. Maybe it's just a matter of just reading this thoroughly. I mean, I need to grab every comment and see what happened. Yeah, kind of exhausting. Oh, anyway, so that's all for now. Thank you very much for synchronizing this live stream. See you until the next time.